After your section descriptions are completed, you can combine some or all of those descriptions into a composite section called a stratigraphic column or strat column. A strat column is created from a metadata file in CSV, comma-separated values, format. This file tells PSICAT what sections to use and where to position them in the strat column. It is easiest to create the file in Excel, but you can also use a text editor. There are two acceptable metadata formats. The first format, section metadata, is relatively simple, and we recommend using it when possible. It consists of 3 columns, a section ID, and a top and bottom depth in meters. The column headers are optional. And the main limitation of the section metadata format is that it always includes the full section contents. You cannot use this format to include a portion or a subinterval of a section in a strat column. The second metadata format, splice interval table or SIT, is significantly more complicated. It consists of 10 columns, many of which are ID components, and then a top and bottom section offset in centimeters, indicating the portion of a section or sections to include, and top and bottom depths in meters that indicate where in the strat column those portions should be placed. In this format, column headers are required. The main advantage of this format is that you can use portions or subintervals of a section, unlike section metadata. If you want to include sections in their entirety, we again recommend using the simpler section metadata format. Now let's take a look at each of these formats, starting with the simpler section metadata. So here is my project. I've described 3 sections from top to bottom. And I want to combine these 3 sections into a strat column. To do so, I'll need to create a section metadata file. And I've already created one here in Excel. A section metadata file consists of 3 columns with 1 or more rows. The first column is the section ID. It should exactly match the name of your section in PSICAT. So this matches my first section there, this matches the second, this matches the third. The second and third columns represent the top depth and bottom depth where that section data should be placed, and these are both in meters. So for my first section, I want to place it from 0 to 1.63 meters in the strat column. Next section will go from 1.63, so its top will touch the bottom of the previous section, from 1.63 to 2.63, and my final section will again touch the bottom of the previous section, starting from 2.63 and end at 4.26 meters. And I've saved this file as a CSV file. If you go to Save As, you should have that option somewhere in the long list of possible formats here. It'll look a little different on Windows, but you should have similar options. So save it as a CSV, which I have already done. And then to use it in PSICAT, go to the File menu, Create New, and choose Stratigraphic Column. In this dialog, click the 3 dots button and navigate to your metadata file. Click Open. And then PSICAT will show you how it matched the sections in your metadata file against sections in your project. So this looks good. This message says found 3 matching project sections for 3 metadata sections. So that's exactly what I want to see. On the left is my metadata, on the right is the matching project section. If you see blanks in the project section column here, that means that things did not match up, and you can continue, but PSICAT will not be including that section in your strat column because it can't find the matching project section. So typically that means your metadata section name wasn't quite right and it doesn't exactly match the corresponding project section. So if you modify, or basically edit your metadata file and try again, then hopefully you'll get a match. And once everything matches, you should be good to move on to the next step. So hit OK once you're happy with the matches. This dialog lets you give a name to the strat column. I'm just going to call it my first strat. And then it lets you choose what components you want to include in that strat column. So there might be things you don't want to include. Maybe I'm not interested in including units in my strat column. You could whittle it down to just beddings if you wanted to. So there's some flexibility there. For now, I will include all of these. We do not typically include images in our strat columns, both because they make the file extremely large with lots of images, and in our case, often we have extraneous color card imagery at the end of our images that cause the section to be essentially too large for the depth range we've assigned it, and that will result in compression of the section in the strat column, which is often not what people want. So I'm going to exclude images here, and unless your images have no extraneous imagery, I would recommend doing the same. Once you're happy with the components you're going to include and the name of your section, you click the Create Strat Column button, and this is a very small strat column, so it happened very fast. Once you see the strat column creation succeeded message here, you can close the dialog, and you'll see here now it has added a new section to your list of project sections. So we can double click that like any other section and open it. And now you can see that my first section, which runs from 0 to 163, is here in its entirety. So this is the individual section, it ends at 163. My next section is about 100 centimeters long, so that should go from 100, oops, go back to the strat column. That starts at the end of the previous section at 163 or 1.63 meters and runs for about 100 centimeters down to here, down to 263, and then my last section starts here. So you can see all three sections have been combined into a single composite section. Also notice that you cannot edit this strat column. You can see there aren't editable fields here. Everything is static, so this cannot be edited. It's also good to understand that this strat column is just a snapshot of the state of the columns you created it from at the time of creation. If we were now to go back to our first column here, if we edited this, if we change this from chert to conglomerate, that change will not be reflected in the strat column. You can see the strat column, that interval is still chert. So again, because it's a snapshot, the contents of the strat column will not update with changes you make to the source columns or source sections after the strat column has been created. It's essentially a snapshot of that moment in time. So if I wanted to capture this change, I would need to regenerate the strat column, and then this interval would be conglomerate. When I created my section metadata file, each section's depth ranges were based on the length of the descriptions in that section. So for example, my first section is 163 centimeters long, and that section ran from 0 to 163, so it matches up. My next section metadata row was 100 centimeters long, or 1 meter, and that matches my section. And the third is also 163. So again, everything matched up. What would happen if I used larger depth ranges? What if I said this section ran from 0 to 2, this section ran from 2 to 4, and this section ran from 4 to 6? I save this file and generate a new strat column based on that metadata. What happens? Again, all three of my sections match up. I didn't change the names, so that's good. Create my second strat. And I'll leave all the included components the same. Click Create Strat Column. It's created very quickly, and if I look at this one, what happens? There's my first section, runs to 163, and now there's just a gap. So PSICAT did not try to stretch out the contents of my section to fill that 2 meter depth range I specified. It said, hey, there's 163 centimeters of description here, I'm just going to use that and create a gap until the start of the next section, which is at 2 meters or 200 centimeters. So here's my second section, which is about 100 centimeters long, and again, no stretching occurred. PSICAT just took the 100 centimeters of content there and placed it in the first half of the depth range I specified for that section. And finally, the third section, as before, was not stretched in any way. It just took the 163 centimeters of description and placed it in the 2 meter range I provided. So that's what happens when your ranges are longer than the contents of the section. Now, what happens if we have ranges that are shorter? Let's say that we know this section is 163 centimeters. What if we make it just 0 to 1? And make this one 1 to, let's do this one 1 to 2. So this should not change because this section is in fact 100 centimeters of description. And then this one from 2 to 3, even though that is also 163. So now our first and third section have depth ranges that are smaller than the actual descriptions. Oops, so I'll save this and I'll generate one more strat column from that. Oops. Oh, come on. Okay. Great, everything matches up. I'm going to call this my third strat. So what's going to happen here? Open it up. You can see here's our first section, and we had a depth range from 0 to 1. And as you can see, it now ends at 100 meters. So we can zoom out a little bit here and see more of it. So what happened, if we look at the original section, so we can see that PSICAT compressed our 163 centimeters of descriptions into the range we gave it because that range was smaller. And so PSICAT will compress that 163 centimeters of material or description to the meter, 100 centimeters of range that we gave it. Our second section was 100 centimeters, so no compression should have occurred. This should match up. And then our third section, again, was 163 centimeters, but we only gave it 100 centimeters of range. And so this, too, you can see, has been compressed. Look at this one, just to compare. So you can see, sort of, it's hard to match things up exactly, but you can see that the contents of the third section have been compressed to fit the 100 centimeter range we provided. So that's very important to understand. If the range you provide in the metadata is longer than your descriptions, PSICAT will just use the descriptions as is without stretching them to fill. But if the range is smaller than your descriptions will be compressed to fit that depth range. Now let's look at the more complicated splice interval table format for creating strat columns. The process of strat column creation and the compression of descriptions we already discussed in the section metadata portion of this tutorial also apply to the splice interval table format. So we'll focus mostly on the format here. It was originally created by IODP for use with its stratigraphic correlation software called Correlator. It has been adapted for use in PSICAT, which creates some complications. In this format, the components of a section ID are broken into separate columns. So you can see we have site, whole, core, core type, top section, and then down here also a bottom section. So instead of a single column with a single section ID, it's broken into components. And this is a vestige of the IODP format. PSICAT will combine these components into full section names and try to match them against your project's section names. As with section metadata, the components should match your section names exactly. If your sections do not use the CSD facility or IODP naming conventions, you may need to fabricate section names to use the splice interval table format. Contact the CSD facility and we can help you with this. Here's an example of a splice interval table that can be consumed by PSICAT to create a strat column. I'll start with the first row. So you can see there are elements of our section ID here split across several columns. PSICAT's going to combine these into a name that matches my topmost section name here. So that's the section that will be used, and the material that will be included in the strat column starts at depth 0 in centimeters, that's the top offset, of my description. So it'll start from the top of my description here, and it will go down to 20 centimeters of my description. So I'm just going to take from 0 to 20 centimeters of this first section's description, and I'm going to place that in total depth, and this is measured in meters, total depth 0 to 0.2 meters, so 20 centimeters. So I'm placing my 20 centimeters of material into 0.2 meters, or 20 centimeters, the first 20 centimeters of the strat column. My second section works similarly, except that's pulling from core number 2, so that's going to be this section. Again, it's going to pull the first 20 centimeters of description of this core, so starting from section depth 0 centimeters and going down to section depth 20 centimeters, so it'll consist of this chalk and this clay. And then it will place that in 0.2 meters of the strat column to 0.4 meters of the strat column. So the next 20 centimeters of the strat column. And then finally, our third section here, which is just nothing but sand, we'll do the same thing. It will just take the first 20 centimeters, so from 0 to 20 centimeters of this section, and place that in the 40 centimeter to 60 centimeter range of the strat column. So that's how this should work. Let's see if it does work. So to do this, we're going to create new stratigraphic column as before, and we'll do the exact same process, except we'll select our sit file instead of our metadata file. Click open. Now you're prompted with this. And basically this is asking you to choose how your section names are delimited, whether it's a hyphen or an underscore or some other special character. For CSD facility sections, we use the hyphen. So I'm going to leave this at the default of hyphen. I want to click OK. As with section metadata, now you see the results of PSICAT's attempts to match your metadata section to sections in the PSICAT project. And this looks good. We found 3 matching project sections for 3 of our metadata sections. There are no blanks on the right side, so that is a good sign. Everything matched up. Again, if you see blanks on the right side, you are going to need to adjust your metadata so that PSICAT can match the project section to your metadata section correctly. But this looks good, so we'll click OK as before, and then follow the same process as before. This is all exactly the same as with section metadata. Choose the components you want to include in your strat column, and when you're ready, click Create Strat Column. To keep this really simple, I'm just going to create a strat column with lithologies and nothing else. So here we go. So now if we look at this, it's named after the metadata file I gave it. If we look at this, we should see 60 centimeters of material. And that looks right. So the first 20 centimeters of material came from our 20 centimeters of tephra in section 1. The next 20 centimeters of material are a chalk and a clay, 10 centimeters each. We see a chalk and a clay, 20 centimeters each, in our second section. And then the bottom, 20 centimeters from 40 to 60, is all sand. And as we know, our third section is nothing but sand. And so we've taken portions of each of those sections and created this simple strat column with them. So for simplicity, the first example pulled the first 20 centimeters of each of our sections, but you certainly don't have to pull from the top of the section. You could do whatever you want. So for example, in this first section, we could pull from 20 centimeters to 40 centimeters, for example. By changing our top offset to 20 and our bottom to 40. And we still have 20 centimeters of space in our strat column allocated for that material, so there will be no compression. Should fit just right. For our second section, we could pull from, let's pull from 10 to 30 here. So again, we'll just change our top offset to 10, our bottom to 30. And then for our last all sand section, it doesn't matter, but let's pull from the bottom. Just as an example, we'll take the bottom 20 centimeters of description here, so 135 to 155. And again, all of those are 20 centimeters long, so they should fit just right into the strat column interval that we have set for them. So I'll save this file, and let's export, or create rather, this strat column. So again, same process. We'll choose our second splice interval table. We'll stick with hyphens as our delimiter. We have 3 matches. That's good. Click OK. Once again, I will only do lithologies to keep it simple. And we'll stick with the metadata name for our section. So I'm going to create. And let's take a look. So now we see our first 20 centimeters consist of the 5 centimeters of chalk, 5 of clay silty, and then we trimmed the first 10 centimeters of this conglomerate portion. So that's our first 20 centimeters, and then our next 20 is a clay and a breccia from our second section. So from 10 to 30 of our second section. And then finally, our bottom 20 centimeters are just all sand. Sand that was from 135 to 155 of our third section. So you can use any depth range you want as long as it is within the bounds of the descriptions of the section. So the first 2 examples of splice interval tables, each metadata row corresponded to a single PSICAT project section. But it is possible for a single metadata row to correspond to 2 or more PSICAT sections, and you do that by changing the values of top and bottom section so that they represent a range of sections instead of a single section. So I'll show you a very simple example of that. Let's say that we wanted to, so here's our first section, here's our second section. Let's say that we wanted to just take from depth 150 of the bottom section all the way to the bottom and then continue into the section following it and take up to 20 centimeters of that section and include that in our strat column. That can be achieved with a single row of metadata. Do that as follows. I'm just going to delete these other 2 rows and just create one from this. So our top section will start in section 1, but we want to start from depth, we'll start from depth 150 here. So I'll change my top offset to 150. I still want to place that at 0 total depth, start from there. Then my bottom section, instead of being section 1, will now be section 2. And I want the first 20 centimeters of description from that core. So my bottom offset will be 20. So this will pull descriptions from both of those project sections in PSICAT. I'll show you that now. If we go to create new stratigraphic column, choose our new splice interval table, as always, hyphen. And you can see, even though we only have 1 row of metadata here, PSICAT has found 2 project sections that correspond. Because PSICAT sees that we're going from section 1 to section 2, and it generates the appropriate IDs for both of these and finds matching project sections for both. So that's exactly what we want to see. So if we click OK and proceed and just create lithologies here, if we look at that, what we should see now is 20 centimeters of material, because the range we provided for the strat column was 0 to 0.2 meters, so 20 centimeters. And the first thing we see is a little less than 8 centimeters of conglomerate, which came from here. And then the first 20 centimeters of the silty clay. And I noticed that we have more than 20 centimeters of material in our source sections, but they have been compressed to 20 centimeters. And that is because, as with section metadata, the length of the descriptions we provided is more than 20 centimeters. So PSICAT is compressing that to fit the section we gave it, to fit that 20 centimeter interval. So we had, let's see, from 150 to the bottom of this section, which is 163, so that was 13 centimeters of material, plus the 20 centimeters of material from this section is 33. So that 33 centimeters of description was compressed to fit the 20 centimeters we gave it. Of course, if we changed our bottom depth here to 0.33 and save splice, then we would see no compression. If we were to generate another strat column here, quickly, let's do that. Same process, we have 2 matches, that's good. Just do lithologies. If we create sit 5 here, we should see that it is 33 centimeters long. So there's no compression here because we gave our descriptions enough space, or there's enough space in the strat column to accommodate our descriptions. And also, as with section metadata, if we provided more space in the strat column range, so if I gave this 40 centimeters of range, then we'd just have 7 centimeters of gap at the bottom of this. PSICAT will not stretch the description to fill that space. It will only compress if the description is larger than the strat column interval provided. So in our last example, we used a single row of metadata to pull data from 2 PSICAT sections instead of 1. So that works and is possible. That is especially convenient in cases where your cores have been divided into many sections, maybe up to 7 sections. And if you wanted to include, start from section 1 and go all the way down to section 6 or 7, this is a nice way to capture all that data in a single row. But as you saw, it is a bit more complicated than including a single section's worth of content at a time. And I just want to illustrate that this approach is one way to achieve what we achieved, but you could also simply do that with 2 rows. So we could simply go from 150 to 163 in our first section. So we would go back to section 1 here. We want to stay in section 1, and we want our bottom offset to be 163. So now we're explicitly taking from 150 to the bottom of this section. And we will place that in the first 13 centimeters of strat column. And then we can just create a second row to pull data from the top of the second section in that sequence. And so it's a little clearer exactly what we're doing when we look at this splice interval table. So let's see, we can copy most of this, change this to section 2 now, and we'll start at site depth 0 in section 2. And we'll start from the bottom of the previous strat column interval there. We'll stay in section 2, and we'll just do the first 20 centimeters. And then we'll go to 0.33, so we have exactly 20 centimeters of space in our strat column for the 20 centimeters of material we're taking here. So save this as sit 6. That's a lot of sits. And export this, or create this rather. See, we have 1 match for each of our 2 rows. So that's good. Hit OK. We'll just create lithologies. And so this should be 33 centimeters of material. The first 13 coming from our first section, from 150 to 163. And then, the last 20 coming from the top 20 of our second section in that sequence. So you can achieve the exact same result with multiple rows. It's a bit more readable and easy to understand when you do maintain the 1 row of metadata corresponds to 1 PSICAT project section idea. So I just wanted to illustrate that there are 2 ways to achieve the same thing, and this way may be easier to understand. The way PSICAT combines the components of a section ID from a splice interval table and uses them to determine matching project sections in PSICAT is something that deserves a little more explanation. So basically what PSICAT will do is it will take your site and whole and combine them together, and then add the delimiter you select. We'll get to that in a minute. And then it will combine core and core type, and again, then add the delimiter that you select, and finally, it will add the section number. The delimiter PSICAT uses to combine these is then what that dialog prompts you for when you choose to create a strat column from a splice interval table. So when I choose the splice interval table, I immediately get this prompt. So this is where you'll choose what delimiter you want to use. For IODP and CSD facility section names, hyphen is the default. For ICDP section names, underscore is the default. So if I were to choose underscore here, then PSICAT would use those to create my metadata section names. But you can see it cannot find any matching project sections because my project sections use hyphen as delimiters. So that will not work. So I have to specify the right delimiter for PSICAT to be able to match things correctly. So that's why I leave this as hyphen. Now I get matches because my section names use hyphens. So that is how PSICAT takes the name components in a splice interval table and combines them to attempt to find matching project sections. So be careful about the delimiter you provide and the naming of your components in your metadata file. But that is unfortunately the most complicated part of creating splice interval tables, is getting that matching just right.